All right, so here's an overview of what we'll be talking about today. So what is Hugging Face? What do we do as a company? What is a vision language model? How do we build a state-of-the-art vision language model? We'll be talking about data preparation, training, evaluations, and benchmarks. And finally, we'll give you a demo of SmolVLM. All right, so what is Hugging Face? Well, you can kind of think of Hugging Face as the backbone of the modern AI stack. We operate at different levels, whether it's hosting models, developing our own models, data sets, evaluation, benchmarks. We even provide GPUs and CPUs for you to demo your own machine learning applications, and really everything in between. And it's usually free, open source, and we try to democratize access to AI knowledge. So what is a VLM? Well, a VLM, or a vision language model, is a type of neural network architecture trained on text and image tokens. So you put in text, images, video, and you have text as output. And there are usually two different approaches for unifying these image and text tokens. We talk about cross-attention architectures and self-attention architectures, and I'll be talking about those two things in the next few slides. So first of all, we have cross-attention architectures, and this is when you have a frozen vision encoder and a frozen large language model. And what you do is you add certain layers between the transformer blocks, and you feed in the image features directly into large language model, and you just train the new layers that you added. You usually do this to preserve language models' capability to actually output text and to actually generate coherent text. And what you do is usually fine-tune each backbone on a specific task before training them together. The self-attention architecture is actually what we use in state-of-the-art architectures. So if you've heard of any of the recent vision language models, either from OpenAI, Hugging Face, Google, etc., they usually use this approach. And what you do is you feed in text and image tokens in the same latent space. You concatenate them and feed them to the transformer model together using different types of positional encodings. And it usually outperforms cross-attention with enough data when trained from scratch. And it outperforms the previous approach with enough data and compute. So using a lot of data, we actually trained our own small vision language model. And for the longest time, it was actually the most performant, smallest vision language model. We created a family of models, so 256 million parameters, 500 million parameters, and 2.2 billion parameters. And if you're familiar with the space, you'll know that these are extremely small models compared to what's out there. So a lot of the state-of-the-art models that you use, like ChatGPT and stuff, are orders of magnitude bigger, usually 100 billion parameters. So as you can see from the graph, we match or exceed performance of other models that were in the space, and we're fully open source. We open source the weights, we open source the data, we even open source the training code so you can actually train your own models and fine tune them for your specific applications, and it has permissive licenses, so it's easy to adopt in your company. And the code is available in both Python and Swift, so you can either deploy in your traditional ML pipeline or on device on iOS, Core ML, etc.